Welcome to Chapter 5 of CPS. In this chapter, we're talking about motion, speed, velocity, acceleration, lots of good stuff. So good, you will be moved. Not really. I'm going to move quickly here because I want to keep this video under 10 minutes. That's my goal. Okay, so this will be the last joke in the presentation, I swear. So what is motion? So motion is an object change in position relative to another object or reference point. So that would be when something moves in reference to something else, right? So here's my reference point here. You only know you're moving when in reference to this original position, okay? So those reference points are known as up, down, southwest, east, right? So you'd say you're moving east down the street. That is moving in relation to a point, you're moving east, okay? The surface of the earth is a common reference point. All right, guys. So in this video, or in this is actually a GIF file, but you can't see it move. More on that in a second. This gentleman right here is the reference point, right? So if he's standing still or relatively still, and this train is moving, right, in this direction, this train is moving in reference to him. So in this case, let's say it's moving west. Okay, the train is moving west. He is staying still. If he was running at the exact same speed as the train, it wouldn't seem like the train was moving, right? Because something seems like it's moving in relation to this reference point. Okay, so in this case, the dude here is the reference point. This is actually a pretty famous GIF file. I couldn't figure out a way to show it in this video, so if you just Google that's not train, sorry, let me delete that. Train changing direction .gif, you will see this. I want you to check it out. It's really cool because this is actually more of a mind trick. You can change the direction of this train, right? So when you first start watching it may go this direction, and if you concentrate hard enough, you can actually make the train go this direction. It's pretty cool. I want you to try it just because it's cool. Okay, so in this example here, it's moving west, right, originally in relation to this reference point. What is speed in comparison to motion? All right, so speed is a distance traveled by an object divided by the time it takes to travel that distance. All right, so with speed we use meters per second is the standard SI unit. If you're traveling faster, you may use kilometers per hour or feet per second, or if you're going really fast, kilometers per second, right? Notice we didn't use miles per hour at all. That is not the scientific standard use, okay? So if you look at your speedometer is telling you your speed, right? So it's telling you how fast you're going in an hour. So if you're looking at your speedometer, your parents are driving 65 miles per hour or 100 kilometers per hour in 1 hour. That is how far they would have traveled. All right, so we say we need two things to calculate speed. We need distance and we need time. Okay. So how do you calculate speed? Well, obviously, again, you take distance and you divide it by time. This is one of the oldest math problems. You should really know this probably from elementary school. But it's going to have to be calculated. You're going to have to do it. So if you look at the graph, you can see you have time down here in the x-axis. So as time goes on from 1 hour to 4 hours, you can see, well, how far have we traveled, right? So by the end of 4 hours, we've traveled 400, well, not quite 400 kilometers, maybe somewhere around 380 kilometers, right? So we've gone, if you divide that by 4, what's your actual average, you can figure out your kilometers per hour might be, whatever 380 divided by 4 is. I'm not going to do that quite right now. Try these. These are on your notes. I want you to try these. If you look at the example we've got here, an athlete swims from one end of the pool, a 50-meter pool. I used to swim, so this kind of brings back memories for me. Bad memories, mostly. You go from one end of the pool, 50-meter pool, to the other in 25 seconds. That's a decent time. What is the athlete's average speed? All right, well, you just take 50 and divide by 25. Pretty easy, right? So this person was going 2 meters per second. Try these, and I want you to write your answers in the space below. I might do a quick check of your notes in class and see that you did this in class. Velocity. So the difference between velocity really and speed is this kind of keyword here, direction, okay? So the speed of an object in a particular direction is called velocity. So it's pretty much speed plus direction, okay? They're very different terms. When you talk about velocity, you have to include a reference direction. So if you're saying 25 miles per hour west, that would be a velocity, okay? That direction, that reference direction, it's not in these notes here, is called a vector. Okay, so the vector is kind of where it's moving or what direction the force is moving. We're going to come back to the word vector when we talk about forces in the next chapter. But the key thing you have to remember between the difference between velocity and speed is the reference, the direction. Okay, speed has no direction calculated into it. If you change velocity, you're changing an object's position. So an object's velocity is constant only if its speed and direction don't change. Okay, so it's Newton's law again, right? It's going to continue moving in a straight line on a constant speed unless another force interacts it, right? So we know that things move, right? And we've got situations where you may have to like add certain velocities together. Those are called resultant velocity. So let's say you are on an airplane, right? Let me quick airplane. Great airplane. There's little Tommy on the airplane. And let me draw a little back fin. Not too bad, right? So you're on your airplane, right? And your airplane is flying super fast, maybe 700 kilometers per hour. And you are getting up. You're going to go back here to the bathroom, do your thing, and then head back to your seat, right? Well, you're moving, right? You have a certain speed as you walk. So you can actually add that velocity, right? That change, that in direction with this one here. That's called the resultant velocity. Here's a much better picture of this example, okay? So you've got, let's call him, I don't know, Patrick Larkin. So Patrick here is on his bus heading to school, and he's walking 1 meters per second east on the bus, okay? So Patrick is walking this speed here. The bus is going this speed. So you can add these two velocities as long as they're in the same direction to get a resultant velocity, right? It's pretty simple. 15 plus 1 equals 16 meters per second east. So notice this is velocity because it has the direction on it, okay? So this is not speed in this case, okay? This is velocity, right? Because we've got a direction. You can actually subtract too. So let's say Patrick is walking in the opposite direction, going back to his seat, going back to the bathroom. You would take away the velocity that's going the opposite direction here. Yeah, so pretty straightforward, right? That is resultant velocity. Acceleration. So the rate at which velocity changes over time is called acceleration. So sort of the change in speed is acceleration, okay? So increase in velocity is called a positive acceleration, and a decrease is most commonly called deceleration, or possibly negative acceleration, okay? So if you think back to the slide we saw before, where, all right, sorry, I had a little technical error there, but I'm going to keep moving on. My program crashed, but I'm going to keep rolling here. So when something slows down, you can think about that as slowing down. I'll change my color, ink. Slowing down. Okay. You can calculate acceleration pretty easily. All right. So you have to find the final velocity, subtract the starting velocity. Okay. So this could be 0. All right. This could be any number, but you have to subtract what you initially start with and divide it by the time it takes to change the velocity, okay? So we're going to use meters per second for velocity. Acceleration is meters per second divided by seconds. So meters per second in seconds, which actually equals down to meters per second squared. Don't be confused by that totally. We'll practice it. But just remember that this is the unit for acceleration. Okay, so in this case here, we've got, who is that? That looks sort of like Someren on the bike there. So Someren is riding his bike. He's beginning at 1 meters per second, right? That's his initial velocity, okay? So his final velocity is 5.1, all right? So, and it took 1, 2, 3, 4, 5 seconds, okay? So remember, you're taking your initial velocity, subtracting it from your final velocity, dividing it by the time it took, which is 5, resulting in 1 meters per second squared. Okay, so that's how you calculate acceleration. So you hear often how cars accelerate, right? It's like a car like going faster. Think about it not as moving, but more how the speed increases or decreases, right? So look at this next slide here. You start at 0, you're ending up at 25. So this is positive acceleration here, and this is negative acceleration here as we are reducing an acceleration from 25 down to 10 meters per second here, okay? Or meters per second squared, excuse me. Okay, doing good here. Last concept is called circular motion. So this is cool. This is one of my favorite things to demonstrate. In circular motion, which is also known as continuous acceleration, an object travels in circular motion is always changing its direction. All right, so think about it. If you're spinning around a point like this, you're not really going north, you're not really going east, you're not really going south, you're not really going west. You're constantly changing direction, right? So at any given time, you're going a different direction as you go around this point. So therefore, its velocity is always changing. Think about that. Remember, velocity involves speed plus direction. So if the velocity is always changing, it's accelerating. Okay, so the acceleration that occurs in this motion is known as centripetal acceleration. Okay, so centripetal just means, in Latin, centripetal means center seeking. So that ball is kind of spinning around that center. So examples of this are the Earth's orbit of the Earth. If you've ever seen someone kind of take a bucket of water and spin it around your head, maybe I'll demonstrate this in class tomorrow. It seems like it's going to spill out and get everyone, but if you spin that around your arm, your shoulder would be that kind of point right here. You can spin it around without spilling the water, right? Because there's a force acting on the water as it goes around here. As you can see in the slide, you have this woman spinning kind of like, I don't know, a yo-yo or something, and it's going around and around and around this point here. So it would continue to go around and around and around this point until the string is released, right? And if the string is released, it's going to continue going at that last release point. It's not going to continue in a circle, okay? Because of inertia, it's going to continue going in the direction that was released on. I'd like you to go to this YouTube video and watch it for a really nice explanation of centripetal force with some cool animations I really can't show you here. So I recommend, it's literally 90 seconds long. Go here, watch this, just take a minute of your time and just get a little bit more info on centripetal force. Centripetal force also explains why you don't fly out of the roller coaster. So, newsflash, those restraints in the roller coaster, they help, but the bigger thing that's keeping you in place is this force the motion of the roller coaster as it continues along here. there is a force acting on you as you spin around in that circle. That's centripetal force. Okay, that's actually what's pushing you in your seat and keeping you there. It's also in that ride, like the UFO ride, as it spins around that central axis point. It's that force that's kind of pushing you up against the wall. I don't know if you've ever ridden that ride at Seabreeze, but it's a good one, and you can kind of move around on that wall and almost like defy gravity because of that. Okay, so thanks to centripetal force, a satellite can orbit around the Earth, so gravity is going to hold it in place. So if you think about that string right here, the string that she's holding, and think about like the string actually is what gravity does for. Let's pretend this is like a satellite right here, and so that satellite is held in place by gravity, right? So like just like that string holds it in place as it spins around the point of the woman's hand. A satellite will spin around the Earth because gravity is holding it in place. Okay, and if for some reason gravity stopped, the satellite would hurtle off into space and never be seen again. All right, so this was a pretty quick intro to chapter 5. I want you to rewatch this a few times if you need to. If you have any questions in class, let me know. It's pretty basic. Motion is explained by speed, velocity, and acceleration. Okay, we're going to delve deeper into this in the next section, where we talk about some other good stuff. Okay, so thanks for watching, and if you are up late, go to bed and have a great night.